my friends, welcome to our fourth class of Unit 6, where today I've got a bit of a game for you. It's an impressions game. I'm going to do an impression, and you're going to tell me what you think I am. Ready, set, go. Okay, did you get it? I'll do it one more time. Listen closely. All right, what did you think? Did you guess A, a crying baby, B, a race car sputtering out on a racetrack, or C, a secret third thing? If you guessed C, you're correct. I am an electric guitar because just like an electric guitar, today we're going to get plugged in and amped up using our laws of exponents, this time for the second time. Now that we've got a pretty good sense of how our laws of exponents work in some simpler cases from last time, the name of the game for us today is iteration. We want to see how far we can push our understanding by tackling some even more complicated examples. Now, I'm going to keep going through each of these one by one. My expectation is that at home, you are giving yourself a couple of minutes, pausing the video, working out each example before we come back and do it together. Sound like a plan? Capiche? Kaposh. Let's go. So for our first example here, 5m squared n to the sixth, all raised to the third power. My strategy, of course, that I remember from last time is when in doubt, I want to chunk it out. So I'm going to take the argument here of my exponential expression, and I'm going to break this guy down into a number chunk, into an m chunk, and into an n chunk. Now that I do that, I know that I can take that exponent of 3, and whenever I have a product of things multiplying together, I can take each factor and individually assign it to that exponent. So from here, it makes it more obvious that I'm cubing each of these factors. Well, 5 cubed, I know is 5 times 5 times 5. That's 125. And then I've got m squared to the power of 3. Here I know when I raise an exponent to an exponent, I multiply my powers. So similarly, this should be n to the 6 times third power. And now I've got, smushing it all together, 125, m to the power of 2 times 3, which is 6, and n to the power of 6 times 3, which is 18. For our second here, negative 4, a to the third, bc squared, quantity, again, just a fancy word for thing in parentheses, squared. So using that same idea, when in doubt, chunk it out. I'm going to break this down into a number chunk containing negative 4, an a chunk, a b chunk, and a c chunk. From here, again, I'm going to take that exponent on the outside and give it to each of my factors individually. So I've got negative 4 squared, I've got a cubed squared, I've got b squared, and I've got c squared squared. All I need to do now is find my squares. Well, negative 4 times negative 4 gives me positive 16. I have a cubed squared multiplying my exponents, so 3 times 2. B squared is just b squared. And then c squared squared, again, I raise an exponent to an exponent, I multiply. Last but not least, smushing it all together, well, I've got 16 times a to the power of 3 times 2, which is 6, times b to the power of 2, times c to the power of 2 times 2, which is 4. And last but not least here, again, I'm going to take my exponent of 4. I'm going to assign it to each of my factors individually. Before I do that, well, let me break everything down as much as possible. So I've got this guy that's going to get raised to the power of 4. Before I even do that, I might notice that I have this QR to the power of 3. So I've got some layers here. Let me unpack this layer. Well, I've got negative 3 over 2 times p squared. And then again, if I have 2 factors raised to a power, I can assign each factor that power individually. So QR cubed is q cubed times r cubed, raising now this whole thing to the power of 4 now that I've got my chunks. Well, I have negative 3 over 2 raised to the power of 4 times p squared raised to the power of 4 times q cubed raised to the power of 4 times r cubed raised to the power of 4. From here, well, I've got negative 3 over 2 raised to the 4th power. Again, remember, I can now take the numerator and the denominator and raise each one to the power of 4 separately. From here, well, I have p to the power of 2 times 4. I have q to the power of 3 times 4. And I have r to the power of 3 times 4. Negative 3 raised to the 4th power gives me positive 81. 2 to the power of 4 gives me positive 16. And then I've got p to the power of 2 times 4, which is p to the power of 8. Q to the power of 3 times 4 is q to the 12th. And r to the power of 3 times 4 is, unsurprisingly, also r to the 12th. Nice! Moving on and moving up. Let's take these two examples. Negative 8x to the 4th, y to the 7th, z squared times negative 9, x to the 4th, y to the 0, z to the negative 1st. Again, we've got some more variables here, but that doesn't mean that it's more challenging. It's just a little bit more complicated. When in doubt, split it up, break it down. I'm going to create for each of my factors here a chunk for each of the numbers and each of the variables. From here, I can now do some commutative property. I can rearrange. So let me reorder my factors so that the number parts are together, so that the x parts are together, so that the y parts are together, and so that the z parts are together. From here, 8 times negative 9 gives me 72. I have x to the 4th times x to the 4th. Here I'm going to add my exponents. When I have two things with the same base that are multiplying, their exponents add. Same thing with the y. So I have y to the power of 7 plus 0. And then for my z's, last but not least, I've got z to the power of 2 plus negative 1. Putting those all together, I'm going to erase my multiplication, write it invisibly by smushing each of these up against each other. So I have 72 times x to the power of 4 plus 4, which is x to the 8th, times y to the power of 7 plus 0, which is 7, times z to the power of 2 plus negative 1, which is z to the 1st. But I don't need to write this z to the 1st, so my final answer I'm going to write as 72 x to the 8th, y to the 7th, and z to the invisible power of 1. Next up, 12 c to the 0 d to the 3rd over 16 c to the negative 3 d. Once again, when in doubt, chunk it out. I'm going to take my fraction and split it down into a number part, into a c part, and into a d part. From here, 12 over 16, both of these have a common factor of 4, so dividing each of them by 4, I'm left with 3/4. C to the power of 0 divided by c to the power of negative 3. When I divide two exponents, I know that those exponents subtract, so this becomes 0 minus negative 3. And then d to the 3rd divided by d to the invisible power of 1, well, this would become d to the power of 3 minus 1. From here, smushing it all back together, I've got 3/4 times c to the power of 0 minus negative 3, which is really 0 plus 3, so c to the 3rd power, times d to the power of 3 minus 1, which is 2. Very nice. Moving on and moving up. 2e to the 3rd f times negative f to the 9th times 3ef to the 0. Here, you'll notice that I have 3 factors, 3 things that I want to multiply together. Again, not any more difficult, just a little bit more complicated. When in doubt, chunk it out. I'm going to break down each factor now into its factors. So for each of them, where possible, I'm going to create a number part, an E part, and an F part. Remember in the middle here, negative something means -1 times something. From here, let me rearrange so that all the stuff I know how to multiply goes together. Well, I know how to multiply 2. I know how to multiply that by -1 and 3. I'm going to regroup so that my e's are together. So let me take e to the third, and I'm going to put it with e. And then last but not least, let me put f with f to the 9th and f to the power of 0. From here, piece by piece, chunk by chunk, we proceed. We persist. We succeed. Okay, 2 times -1 times 3. 2 times -1 is -2. Times 3 gives me -6. I have e to the third times e. When I multiply, I add my exponents. So this becomes e to the power of 3 plus, right, that invisible 1 attached to the e. Same thing with this f. This is going to be f to the power of invisible 1 plus 9 plus 0. From here, all I got to do is simplify. Smushing everything together, well, I've got -6. E to the power of 3 plus 1 is e to the power of 4. F to the power of 1 plus 9 is 10, plus 0 is still 10. So -6, e to the 4th, f to the 10th is my final answer. For my next one, 50, parentheses, u, -2, v, all to the power of 2, then with a w outside, is divided by -20, u, v squared, w to the -3rd. So I want to chunk it, but before I do, notice that I've got these parentheses up in the top that are going to give me a little bit of grief. Well, here, taking that numerator, I can now take that exponent of 2 on the outside and give it to each of those factors individually. So this would become 50 times, I've got u to the power of -2 squared times v squared, giving it to each of those factors individually, and then my w on the outside, and then on the bottom, I've got -20 u v squared and w to the -3rd. Simplifying that numerator as much as possible, well, I've now got 50 times u to the power of -2 times 2. Whenever I raise an exponent to an exponent, I multiply my powers. So now I've got times v squared times w over -20 times u times v squared times w to the -3rd. Notice I'm showing too much work. I can never go wrong by showing too much work and over-supporting myself. From here, last step, I'll simplify that numerator even further. This is going to be u to the power of -4 times v squared times w over -20 times u times v squared times w to the -3. From here, when in doubt, chunk it out. I'm going to make a number chunk, so I've got 50 divided by -20. I'm going to make a u chunk, so I've got u to the power of -4 over u. I'm going to make a v chunk, so I've got v to the power of 2 over v to the power of 2. And then I've got a w chunk, w over w to the power of -3. 50 over -20, I can divide both of those by 10. This becomes -5 over 2. I have u's, u to the power of -4. I'm dividing, so I subtract. There's an invisible 1 here attached to this u, so this is -4 minus 1, times v squared divided by v squared would be v to the power of 2 minus 2. And then I've got w divided by w to the -3rd. Again, I subtract my powers. So w to the invisible first would give me w to the power of 1 minus -3. Keep it moving. I've got -5 over 2 times u to the power of -4 minus 1. So this would be u to the power of -5. V to the power of 2 minus 2 is v to the power of 0. And then w to the power of 1 minus -3 would be w to the power of 1 plus 3, which is 4. From here, all I've got to do, well, I've got -5 over 2. I know that a negative exponent is asking me for the reciprocal of the positive exponent. V to the power of 0 is 1, and w to the power of 4. From here, let's combine some fractions. Well, multiplying anything by 1 is just 1, so I can ignore this guy. Let me rewrite w to the 4th as w to the 4th over 1, multiplying across my numerators times numerators, my denominators times denominators. Well, I've got negative 5 times 1 times w to the 4th. This is 5w to the 4th over 2 times u to the 5th times 1. Well, that's just 2u to the 5th. Gross, but doable.